All right, so this is the first of a couple lessons. Well, it says solving two-step linear equations. I don't want us to get too hung up on it. It has to be 2 steps, but generally these equations can be solved in 2 steps, but we don't need to be locked into that. There's always countless ways of solving an equation. And what does it mean to solve an equation? It means to find the value of the missing variable. So in all these equations here, there's a variable. And if you're asked to solve an equation, that means you're trying to find what is that variable represent. What number is a in the case of this first one? Because in this equation, 2a take away 3 equals 1. A can only be one particular number. There's only one number such that this equation is actually true, so that 2 times this number take away 3 actually equals 1. And so what is that number? That's what it means to solve an equation. And in general, we can solve any equation, regardless of the complexity, in theory by performing inverse operations to both sides. And for example, 2a take away 3 equals 1. To figure out what a is, I need to at some point, it would be nice if there wasn't this 2 in the front, which means 2 times. And it'd be nice if there wasn't this minus 3 after it, because in the end, if we can get it to just a equals something, then we're done. What does a equal? And I'm assuming this is not a brand new idea. Although it's the first time in this course we've really focused on solving equations. And so the first thing I would represent is, just take care of this minus 3. That's pretty easy to get rid of. Take away 3. The opposite, or the inverse of subtracting 3 is adding 3. So we add 3 to both sides of this equation. Imagining it's almost like a balance, and the equal sign is what balances the left side and the right side. And we can do whatever we want. We can perform any operation we want to both sides, as long as we do the exact same thing to both sides. And then we keep this equation balanced. And by doing that, if we add 3 to both sides, on the left-hand side, all we have left is 2a, because minus 3 add plus 3 is a 0 pair. Makes 0, and so you have 2a plus 0, or 2a minus 0, or just 2a. On the right-hand side, we have 1 plus 3, which is 4. And suddenly it becomes pretty obvious what this number a must be. 2 times a equals 4, so what's a? Well, I can see that a equals 2. I can just see that now by inspection, because I know that 2 times 2 is 4. That said, you could also, don't expect to always be able to just see the value by just looking at it. And so 2 times some number equals 4. If you're not sure, you can just divide both sides by 2, because division is the inverse of multiplication. And that 2 in front of the a means 2 times a. We always think in opposites, or inverses is the best phrase. And there's our solution. A equals 2. So this equation is only true when a equals 2. And this idea of not just trying to look at the number at the equation and try to just guess and check in our head, the idea of actually performing inverse operations to both sides is so incredibly important. And it allows us to solve these without ever having to make a guess. Because we don't have to guess. I know the inverse of subtraction is addition. I know the inverse of multiplication is division. It's not about guessing. And so if we look right here, I want to know what b is. So that 12 equals 4 minus 5 times some number. Well, I don't know what b is, but what I can do first is I can get rid of that 4 in the front. This 4, this constant term of 4, is a positive 4. So I can, the inverse of positive 4, if I subtract 4 from both sides, that term is gone. So on the left-hand side, all I have is 8. 12 minus 4. On the right-hand side, I got to be careful. 4 take away 4 is 0, but I still have subtract 5b. Or I can think of it as 0 minus 5b, which is the same as just minus 5 times b. Really easy to miss that minus there and just have 5b. But again, 4 take away 4 is 0, and 0 take away 5b is the same as negative 5b. And so now I can't tell by just looking at this what b equals. I can see I'm multiplying b by negative 5 to get 8. 8 is not a multiple of 5, so I know it's not going to be a whole number. And so again, if I want to figure out what b is, I just got to think about what's the inverse. Don't know why my marker gets so big sometimes. I got to think about what's the inverse of multiplying by negative 5, because right now b is being multiplied by negative 5. So what's the inverse of multiplying by negative 5? Dividing by negative 5. So I divide both sides by negative 5. And so on the left-hand side, all I have is 8 divided by negative 5. It's a negative number, and if I decimalize it, which we don't really have to, we can leave it as a fraction, but I'll decimalize it, it's negative 1.6. So in this case, to solve b, I subtracted 4 from both sides, and then I divided both sides by negative 5. All right, so let's look at this one here. I have c divided by 3 minus 2 equals 7, or 7 equals c over 3 minus 2. Again, the first thing I would do, and I don't have to, but I would always recommend just, for example, there's on the side with the variable, with the c we're trying to figure out, if there's a constant term, just cancel it out right away. It's easy to do. In this case, if there's a -2 there, we just add 2 to both sides. And so you have 9 equals some number divided by 3. And just like that, it gets considerably easier, I should say. Now again, you may be able to tell by inspection, but we got to be careful. So some number divided by 3 equals 9. If you're not sure, just multiply both sides by 3. Because again, right now c is being divided by 3. Multiplication is the inverse. And the idea is that if we multiply by 3 and divide by 3, they cancel each other out. They make 1. And so all I've left is, on the right-hand side, is just 1c, which is what we're trying to figure out. What is c? 1c. On the left-hand side, I have 27. So c equals 27, or 27 equals c. Very similar question here. Again, what is d? First thing I would do is get rid of this constant of 5. That's on the same side as the variable, so -5 from both sides. So I have minus d over 5 remaining equals 15. Very easy to miss the negative, but we saw that in a previous question. Essentially right here, when these cancel out, I have a 0. 0 take away d divided by 5 is the same as negative d divided by 5. So what can I do next? Well, if I want to get rid of the division by 5, I can multiply both sides by 5. If I just do that, though, I still have that negative in front of the d, because I canceled out the division by 5. I want to figure out what d is, not negative d. So what can I do about that negative? Well, I can just multiply both sides by -5 if I want. Again, I can do whatever of these basic 4 operations. I can perform any of them that I want to both sides, as long as I'm not just dividing both sides by, or multiplying both sides by 0. Aside from that, which just makes everything 0, that doesn't do me any good. I can perform any operation I want, but in this case, you know, it's a matter of thinking about what operation is useful. And we also want to think in inverses. And so in this case, I'm dividing by 5, so I multiply both sides by 5, but there's still the negative, so that's also multiply both sides by a negative. And so on the right-hand side, I have 15 times -5, which is -75. On the left-hand side, all I have left is d, because the 5's canceled out and the negatives made a positive. And so d equals -75. Last 2 examples, which are not so much harder, it's just more annoying. So I'll mention a couple ways of approaching this. So I want to figure out e, and I have these decimals here. But that's it. You're allowed a calculator. The decimals are just, they're not whole numbers. So the first thing I would do is, again, get rid of the constant by applying the inverse of that to both sides. So if it's -1.5, let's add 1.5 to both sides, which means I have 1.2 times e on one side, and 2.3 plus 1.5, which is 3.8 on the other. OK, and so now to figure out what this e is, I got to divide both sides by 0.12, because right now it's 0.12 times this number e, and the opposite of multiplying by 0.12 is dividing by 0.12, and divide both sides by 0.12. And if I go to my calculator, 3.8 divided by 1.2, 3.8 divided by 0.12 is 31.6 repeating. So I'll put the little bar over it. So like I said, it wasn't so much harder than before, just maybe a bit more annoying because I had some decimals. And it's easy to, I guess your calculator becomes a little more useful. That's it. I do want to mention another approach that when you have a lot of decimals that you may prefer, although again what I did here is totally fine. And again, notice it's been 2 steps. Another option that you may prefer for this, I'll mention for this last one, if you have a whole bunch of these decimals, is again, I can apply any operation I want to both sides, as long as it's the same operation to both sides. I kind of would find this nicer if there weren't any decimals, and I can deal with that right away if I just immediately multiply both sides by 100. Why 100? Because when you multiply by 100, you move the decimal 2 spots to the right. And if I move all these decimals 2 spots to the right, I no longer have any decimals at all. And again, this will give me one extra step, but it'll immediately make my numbers look a bit nicer. So if I multiply the left-hand side by 100, I have 310. If I multiply the right-hand side by 100, I have 1 minus 120f. Again, move the decimal 2 spots, 2 spots, 2 spots. That's a nice thing about multiplying by 10 or 100. In general, you can, anytime you have a decimal, if you want, you can multiply, you can multiply both sides by some multiple of 10. and you'll make, eventually you can get rid of those decimals, unless the decimals repeat forever. With that said, I added an extra step, but by doing that, I have what you may feel are cleaner numbers. Okay, and with that said though, I still have to figure out f. I would subtract 1 from both sides to get rid of that constant of 1. So I have 309 equals negative 120 times f. Right? It's still easy to miss that negative in front of the 120. And then if I want to figure out f, just divide both sides by negative 120. And so not surprisingly, I can see I'm not going to get a whole number. So 309 divided by negative 120 is negative 2.575. And that's an exact answer. So I could have done the exact same thing to the last question. In this case, because I also had 2 decimals right here, I could have multiplied everything by 100. I would have got something similar in terms of my work to what you see here. And again, likewise, I could have skipped this first step and just solved this equation here, just like I did for this one here. So many options. You never want to think about the one way of doing something. There's never one way of solving any equation. There's always countless, which is another way for infinite. But there's usually 1 or 2 kind of most appropriate ways or quickest ways. There's a lot of approaches that just make it needlessly complex. That's never a good idea. But we never want to think there is one way of doing any of these. But there's usually 1 or 2 most common ways of approaching it.